Okay, so if you're listening in and you happen to be getting ready for like a big senior software engineer interview, and especially if they're going to grill you on system design, well, you're in the right spot.
Absolutely. And, at the senior level, interviewers are really looking past, do you just know the patterns? It's more about, do you understand the why, the when to use them, and how they really help build those rock solid systems that are easy to maintain, you know what I mean? So that's what we're going to do today, is give you that deeper dive for a pattern that honestly can be a total game changer in certain situations.
Yeah, for sure. So our mission for today is to really get under the hood of the prototype pattern.
Yeah.
We'll break down, what problem does it even solve? How does it work? Its magic with all this cloning stuff. What are the big wins you get from using it? And then, of course, when's the right time to pull it out of your toolbox? By the end, you won't just know how the prototype pattern works, but you'll be able to confidently explain its benefits, all that good stuff in your interview. So let's jump right in.
Sounds good. Let's kick things off by understanding the problem that prototype really tackles. Imagine this. You're building a super flexible graphical editor framework, right? It's got all those fundamental tools for you to manipulate visual elements. Now, let's say you need to build a music score editor on top of this framework. You'll need to introduce all these specific music objects like notes, rests, and staves.
Right, right. So you've got this kind of generic tool from the framework that's supposed to create any graphical element. But now we have to deal with these musical notations like a quarter note or a whole note, a staff. They're very specific to our music editor. Yeah. The framework's graphic tool right out of the box. It doesn't know how to make these special music classes.
Exactly. You might think, okay, let's just create a ton of subclasses of graphic tool for each music object, like a quarter note tool, a whole note tool, a staff tool, and so on. But then you run into this massive problem. You end up with a ridiculous number of subclasses that are all basically doing the same thing. They just create slightly different musical objects.
Yeah, that's a classic code smell, right? We should be thinking about better ways than just exploding the number of subclasses.
Yeah.
Object composition comes to mind, right? Building up more complex behavior by combining simpler objects. But then the question is, how does that framework's generic graphic tool know which specific type of graphic to make without defining this massive set of individual subclasses?
That's the million-dollar question, and that's where Prototype swoops in and saves the day. The core idea is to let the graphic tool create new graphic objects by copying or cloning an existing instance. That's the prototype. So instead of telling the graphic tool exactly which class to create, you give it a sample, a pre-made object of the type you want, and basically say, hey, make me another one just like this one.
Got it. So it's like we're configuring the graphic tool instead of hard coding what it should create. We give it an example of the prototype and say, build something based on this model.
Exactly. And the key here is that all these graphic subclasses, they all have to support a clone operation. This lets the generic graphic tool work with any kind of graphic object through this consistent interface. It doesn't need to know the nitty-gritty details of each subclass.
Ah, I see. So in our music editor, each tool would actually be an instance of this graphic tool, but each one would have a different prototype associated with it, like one for a quarter note, one for a whole note, a rest, a staff, and so on.
You got it. Now, for the folks prepping for interviews, here comes the good stuff. What are the big advantages of this approach in terms of software design and maintainability?
Yeah, we'll dive into that because ultimately that's what the interviewers are going to want to hear about.
Right.
Not just what the pattern is, but why it's a good choice.
Exactly. One major plus is the flexibility you get at runtime to add or remove different product types. Let's say you need to introduce a new, maybe even more complex musical symbol. With the prototype pattern, you just create an instance of this new notation and register it as a prototype with the tool. Boom, you're done. A brand new tool to create the symbol is ready to go in your editor without changing any existing code or creating new tool classes.
Okay, that's huge. It sounds like it really decouples the object creation logic from the specific types of objects being created. What else should we be aware of?
Another awesome benefit is being able to specify new objects just by tweaking their values. Remember our music editor? Do we really need separate classes for whole note and half note? Probably not. We could just have one musical note class with properties like its visual representation and its duration. The whole note tool would then just be a graphic tool with a musical note prototype that's set up with the right bitmap for a whole note and its duration. The half note tool would use the exact same graphic tool, but with a musical note prototype initialized with the half note's visual and duration.
Okay, so it's about using object instances as these pre-configured blueprints instead of defining a whole new class for every tiny variation. That seems way more efficient for managing complexity.
Absolutely. And it's not limited to just simple values. You can also specify new objects by changing their whole structure. Think of a circuit design editor. People might create these super intricate reusable subcircuits. right? Made up of all these different components connected in specific ways. With the prototype pattern, users can save those complex subcircuits and then just instantiate them again by cloning a prototype of that whole subcircuit.
And in that scenario, a deep copy is super important, right?
Yeah.
You wouldn't want changes to a new copy of that subcircuit to accidentally mess up the original saved blueprint.
Absolutely. That cloned object needs to be its own independent thing. Another big win is reduced subclassing. We touched on this with the graphic tool example. Now think about the factory method pattern, where you often have this whole hierarchy of creator classes that mirrors your product class hierarchy. Prototype lets you bypass that whole mess. By cloning a prototype directly, you often don't need that parallel creator hierarchy. It's especially useful in programming languages where classes aren't treated as first-class objects, where you can't just pass classes around and manipulate them like regular variables.
Interesting. So in those environments where you can't easily handle classes as regular data, the prototype pattern gives you a much cleaner way to create objects based on these existing examples.
Exactly. And one last perk worth mentioning is that Prototype allows for dynamic configuration with classes. Some applications need to load classes while they're running. If you want to create instances of those dynamically loaded classes, you can't just refer to their constructors in your code because those classes weren't even there when you compiled it. Prototype solves this beautifully. The runtime environment can automatically create an instance of each loaded class and register it with a prototype manager. Then your application can just ask this manager for a prototype of that dynamically loaded class and clone it whenever it needs to. It's a technique used in frameworks like ET++ to deal with this dynamic class loading stuff.
So we've looked at some seriously cool advantages. Now, for our interview preppers out there, when is the prototype pattern the right tool for the job? What are the signs that it's a good fit for a problem?
Prototype shines when your system needs to be independent of how its products are created, composed, and represented. Specifically, think about using it when you don't know the exact classes you'll need to create until runtime, maybe because of dynamic loading or configuration. Also, when you want to avoid the headache of creating those parallel class hierarchies of factories and the products they make. Or if you have the classes where instances only have a handful of different states, then it's way more efficient to clone those pre-initialized prototypes than to manually set up the state of each new object.
So it's about having flexibility in how you create objects, simplifying those complex class structures, and being efficient when you're dealing with objects that often need the same initial setup.
You got it. Now let's quickly look at the structure of the prototype pattern. At its core, you have a prototype interface defining that clone operation. Then you have your concrete prototype classes, the ones that actually implement the clone operation. Finally, you have the client, which is the part of your system that creates new objects by asking a prototype object to clone itself. Think back to our music editor. Graphic would be the prototype interface. Concrete classes like staff, a whole note, half note would be concrete prototypes, and the graphic tool would be the client.
Pretty straightforward in terms of the roles involved.
Yeah.
But what are some of the real-world challenges or things to watch out for when you actually implement this pattern?
The biggest hurdle is usually getting that clone operation right. It can get pretty tricky when your objects reference other objects, especially if you have those circular dependencies. You have to decide if you need a shallow copy where the new object shares references to the same underlying objects as the original, or a deep copy where you duplicate the entire object graph, creating completely separate copies. For complex objects that you want to use as prototypes, a deep copy is usually the way to go to make sure the original and the clones are truly independent.
Right, because you wouldn't want modifying a clone subcircuit to somehow corrupt the original template you have saved.
Exactly.
Yeah.
Now, another implementation detail to consider is how you're going to manage all these prototype objects. When the number of prototypes isn't fixed or needs to change on the fly, you might want a prototype manager. It's basically a registry storing and letting you fetch prototypes using a specific key. Clients don't have to deal with the prototypes directly. They just ask the prototype manager for the one they need. This adds a level of indirection and lets you dynamically add or remove prototypes while the application is running.
So the prototype manager is like a central library of blueprints, and the client can access them without needing to know the details of how they're stored or managed.
Exactly. One last thing to think about is how you'll initialize those cloned objects. Clients will sometimes need to set specific initial values on a new clone. You can't always pass those initialization parameters directly into the clone operation because the number and types of parameters might be different for different prototype classes. That would mess up the consistency of the cloning interface. So a common solution is to have setter methods or a separate initialize operation on the cloned object. The client can call this after cloning to set the desired state, but be careful when reinitializing parts of a deeply copied object. You don't want any unexpected side effects.
Okay, these are some great practical points that highlight the finer points of using the prototype pattern effectively. Can we walk through a concrete example to really make it sink in?
Absolutely.
Yeah.
Let's go back to that classic maze game idea, but this time let's add some flexibility in the types of components that make up our mazes without creating a ton of specific factory classes. We can do this with a maze prototype factory. This factory starts with prototype objects for each basic maze component: a maze, a wall, a room, and a door.
So when you create a maze prototype factory, you give it example instances of each maze element that you want to be able to create.
Right. Now, when you need to create a new wall in the maze, instead of calling a specific constructor for a wall class, the maze prototype factory just calls the clone method on its pre-configured wall prototype. Same thing for creating rooms and doors. For doors, you might even have an initialize method that takes the two connected rooms as arguments, and that gets called right after the door is cloned.
I see. So if you wanted to make a different type of maze, like one with walls that can explode and rooms that have bombs in them, you wouldn't need a whole new factory. You would just create a maze prototype factory and give it prototype instances of bombed wall and room with a bomb instead of the regular wall and room prototypes.
Exactly. The make wall method in the maze prototype factory would still just call clone, but now it would be cloning a bombed wall object, even though it might return a pointer to a base class like wall. It would actually be pointing to a brand new bombed wall.
The code using the factory doesn't even need to know the exact concrete type being created. This example shows how you can change the types of objects being created at runtime just by giving different sets of prototype objects to the factory. That's a great illustration of how powerful and flexible prototype can be. It's like having a universal cookie cutter, the factory, that can make different kinds of cookies. The maze components, based on the shape of the dough, you give it the prototypes.
I like that analogy. And this isn't just theory. Prototype has been used successfully in a ton of real-world systems. One of the earliest examples was in Ivan Sutherland's Sketchpad system ThingLab, which is this constraint-based simulation system, also used prototypes extensively. It let users define composite objects and then easily reuse them by adding them to a library as prototypes. And even in more modern systems like the etgdb debugger front-end prototypes are used to dynamically load debugger adapters.
Yeah.
Oh, and remember that music editor scenario we talked about? That was inspired by the Unidraw drawing framework, which relies heavily on prototype.
Wow, it's amazing to see how this pattern has been applied in so many different areas of software development.
So to wrap things up, how does prototype relate to some of the other design patterns that people going for senior level interviews should know? Prototype has some interesting connections with other creational patterns. Prototype and abstract factory can be seen as different ways of abstracting object creation, but they can also work together. For example, an abstract factory might internally use a bunch of prototype objects and clone them to produce its objects. Also, designs that use a lot of structural patterns like composite and decorator can often benefit from prototype. It can simplify creating and setting up those complex object structures that those patterns often involve.
So it can be a standalone solution for object creation or a helpful addition when used with other design principles. So as we wrap up this deep dive, what's the key takeaway for our listeners who are busy getting ready for their senior level technical interviews?
The main thing to remember is that prototype gives you this flexible and powerful way to create objects based on existing instances. It helps you avoid the rigidity of directly creating concrete classes, reduce the need for those parallel class hierarchies, and configure the types of objects your system creates while it's running. Showing that you understand this pattern demonstrates a deeper understanding of object-oriented design and gives you some great talking points when you're facing those design questions in your interviews.
For sure. And as you keep prepping for those interviews, here's something to think about. Think of a project you've worked on, or a system you know where you didn't know all the types of objects you'd need to create until the program was actually running. How could you have used prototype in that situation? What would the benefits have been? What challenges might you have faced? Exploring questions like these will definitely make you a stronger candidate and help you nail those technical discussions. Thanks for joining us today.
My pleasure.
See you next time.